Hello students, welcome to the Chapter 11 review packet. We're going to be talking about how to find the area of the different shapes in the problems you see in this packet. The directions are that all work must be shown to receive credit. Draw out the figures. If there's no figures, you're going to draw them. Round the answers to the nearest tenth, so that's the nearest first decimal place. If necessary, include units in your answers. So let's get right into it. Number one, find the area of a parallelogram with a base of 6.3 centimeters and a height of 3.6 centimeters. So if you're going to draw that, there is no picture on this one. We should draw a sketch of that. And so a parallelogram, this would be an example of a parallelogram with a base of 6.3 centimeters and a height of 3.6. The height is always the perpendicular part that connects the bases here. So that's what I'm looking for here. The area, though, of a parallelogram, it's just base times height. So you've got 6. And come on, my pen was skipping a little bit there. Here we go. It looked like a G instead of a 6. So 6.3 times 3.6, and that should be 22.7 rounded to the nearest tenth. So it says that in the directions. We're going to say that centimeters squared would be my units. It's an area, so I'm multiplying centimeters times centimeters to get centimeters squared. For number two, it says to find the perimeter of a square whose area is 256 inches. So here's a sketch of a square. We know that all sides would be the same on a square. We also know a square is a special type of rectangle. So that means the area would be base times height. But here you could think of all the sides being the same. I'm going to call it S for the side length. Really, we have area is the same as side times side, or side squared. And then that area is 256. So if the area, 256, is the side times itself, you could take the square root of both sides at that point to get just one side. So here the side would be 16. So we know that this equals 16 and this equals 16. These are in inches because the area is inches squared. So take that then, and each one of these around the outside is going to be 16. Since this is a square, they're all the same. The perimeter is what we're trying to find. The perimeter would be either 16 times 4 or 16 plus 16 plus 16 plus 16 is literally what the perimeter is. Add all the sides up. So I'm just going to write 16 times 4. Because that's the simpler way to write that. That would be 64 inches all the way around. For number three, find the perimeter and area of the parallelogram. Perimeter, we would just add up all the sides. We know a parallelogram, opposite sides are congruent. So this is the case here and here. So that's 20 and 30. This would have to be 20 centimeters and 30 centimeters as well. So that's an easy question, at least, to answer the perimeter. Perimeter is just 20 plus 30 plus 20 plus 30. As always, show where you're getting your answers. So that is how we arrive at 100 centimeters for the answer there, for the perimeter. The area of a parallelogram is still base times height, but we don't know the height on this one. So here you have a right triangle. It's a 30, 60, 90 right triangle because of the 60 degree mark there and the 90 degrees there. So this is going to be 30 degrees, and for your ratios, we have that 1:2 rad 3 ratio with these kinds of problems. So this is a 2 times whatever you got, 2x, and this would just be a 1x down here. The long leg, that's the part that's not quite as big as this, but it's a little bigger than this. That's the square root of 3 part. So this is the x times the square root of 3 parts, about 1.7 times bigger than that one. So if we know this one and we want to go back to this one, we need to divide by 2. So this one then is going to be, we'll do that in green here, this one dividing 20 by 2, I'm going to get 10. And then to get from this one to this one, I need to multiply by the square root of 3. So that is going to be, why don't I use a dot for the multiplication instead of an x, so times the square root of 3. And that would make that 10 times the square root of 3 right here. So the height, your h, is 10 times the square root of 3. Now you could use trigonometry to figure that out as well. You could say that it would be the sine of 60 would be opposite whatever this is over hypotenuse 20. So you could say sine of 60 is, you could call this x or h for height over 20 and solve for h from there. That's another way, an alternate way to do this problem. But the base of the parallelogram was 30. The height connecting the parallel parts is going to be 10 times the square root of 3. So you have 30 times 10 square root of 3. And then to the nearest tenth, that would be 300 times the square root of 3. That typed into a calculator, that would give you 519.6, approximately that many centimeters. And this is area, this is going to be centimeters squared. Number 4 says, given the coordinates of the vertices of a quadrilateral, find the area of the quadrilateral. So here's the given vertices. Let's plot those points. Negative 5, 1, 1, 2, 3, 4, 5, and 1 right there. That's point D. 7 and 1, 1, 2, 3, 4, 5, 6, 7, and 1. That's going to be point H. 4, negative 4, 4, and then down 4. That's F, and then negative 8, negative 4. That's going to go back one farther than what the graph goes to, so we'll just go off the graph just a scope there. That's going to be G. If we connect all those, and why don't I use my straight line tool to do that a little more accurately there, a little more precisely. So connect all those. I have, looks like a parallelogram. So here we're saying that you're not having to prove that it is a parallelogram. You can assume the way it looks is what it is. So it looks like this is sloped. You're going up 5, right 3. You're going up 5, right 3. So the same slope here. And then these are slopes of 0. So that definitely is a parallelogram because of that. So we're going to use the area is base times height. That's always our area for a parallelogram. But here our height is always that part that connects the perpendicular bases here. So this height is, just count the number of spots, count the number of jumps. So you're going 1, 2, 3, 4, 5 up. So your height right there is 5, and then your base, just count. This would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So your base is 12. You could also think about that being the difference between the x coordinates here and the difference between the y coordinates going this way with these points. So we have the base 12 and we have the height is 5. That altogether 60. There's no units given on this one, so you could say units squared. Moving on to number 5, given the coordinates of the vertices of a quadrilateral, find the area of this quadrilateral now. So we've got some different points on this one, 0, 4, 4, 6. This one looks like it all lies in the first quadrant or on the axes themselves. So 0, 4, that's going to be 0, and then 4 up right there is M. 6, go to the right 4, go up 6. You have a point right there. That is N. 6, 2 would be right here. That is O. And then 2, 0 would be right here. That is P. So let's connect those and see where that leaves us. See what that leaves us with. So here, I'm saying you don't have to prove what kind of quadrilateral it is. You can assume that the way it looks is what it is. So here, though, you do need to figure out, well, either using the distance formula or the fact that you have some right triangles that you could form off to the edges here. You need to figure out what the lengths are of those things are. We can tell, just looking at this, that we have, this is 2 by 5. This is a 2 by, not by 5, by 4, excuse me. So 2 by 4 right triangle, a 2 by 4 right triangle here. You've got another 2 by 4 right triangle here, and another 2 by 4 right triangle over here. So that's the case. All these are the same. This would be a slope of 2 over 4 here, and this would be a slope of the same thing, 2 up 2 over 4 here. So these have the same slope, And then these two have the same slope, negative 4 over 2, negative 4 over 2. All those could reduce down to 1/2 and negative 2 respectively there and there. So we have slopes that are both opposite reciprocals and slopes that are equal to each other across from each other here. So the sides that are across from each other have the same slope. The opposite sides are parallel, in other words. So here we have, because of all that, opposite reciprocal slopes. This has to be right angles here. These have to be right angles here. And we notice that these are all going to be congruent. So mn squared, the hypotenuse squared would be 2 squared plus 4 squared. So that's going to be mn squared equals, this would be 4 plus 16, so 20. That means mn equals the square root of 20. We're taking the square root of both sides right here. And because these are all the same size right triangles, I could say that's the same thing as the rest of them. I'm going to move this. I keep putting that here. That's better. All right. So we've got mn would be that. It would be the same as no, and it would be the same as op, and that would be the same as pm as well. So all of those are going to be the same distance. You have a square then. So the area of this quadrilateral, base times height for a square. The base and the height are the same. Square root of 20 times the square root of 20. The height, remember, is the parts. Any one of these parts could be a height. If you said this was the base, then this would be the height, connecting the base to the base in a perpendicular way. We have the square root of 20 times itself, so that is 20, and that would be units squared here. No units are given, so that would be my answer. Number 6, find the area of a right triangle whose side lengths are 3, 4, and 5 meters. So I'm going to try to draw a right triangle relatively to scale. So I'll say that's about 3, 4, and 5 for that part. It's a right triangle, so that's going to be my right angle. 3 meters here, 4 meters here, 5 meters here. The area of a triangle is 1/2 base times height, half of a rectangle. You could make a whole rectangle if you had another triangle just like it right here. And so we have 1/2, and then base would be any parts here in the triangle you see that are perpendicular to each other. So 4 is perpendicular to 3. This could be the base, and this could be the height with respect to that base. So this would be 1/2, 4 times 3. Half of 4 is 2. 2 times 3 is 6. This would be 6 meters squared. Number 7, finding the area of the figure. We are going to assume it's not labeled here. We're going to assume that that is a right angle. The area of a triangle is 1/2 base times height. You're given the base and the height perpendicular to that base, so we just plug those numbers in. So 1/2, 5 times 2, and half of 5 times 2 would be, this would be 10, half of that would be 5. So we have 5, and this would be, meters are my units, so meters squared for the area. Number 8, find the area of an isosceles right triangle, hypotenuse length of 25 centimeters. So this is an isosceles right triangle, so I know that it's both right and isosceles. I have to have a right angle in there somewhere, so I'm going to say that that one is my right angle right here. I can draw that a little better in just a second. So this is my right angle, and this is isosceles, meaning that this one and this one have the same length, have the same measure. So I don't know what those two are. I'm going to just say they're x and x, and then this one is going to be 25 centimeters down here. So the area of any triangle, again, 1/2 base times height. The base and the height have to be the perpendicular parts to each other. So it has to be this and this. It has to be that x here and that x here. A couple of ways you could tackle this one. You could use 45, 45, 90. Because this is a 90-degree angle here, this is an isosceles triangle, these base angles here and here have to be equivalent. So you could use the ratios there. If you remember those ratios, it would be 1, 1, and then rad 2. So we have 1x, and x times the square root of 2 if you want to think of it like that. So we're going from the square root of 2 part to the 1 part. You would have to divide by the square root of 2. So if we're going to do that, I'll do that here. We've got x is going to equal 25 divided by the square root of 2. And we could leave it like that. We're used to getting that in simplified radical form though, so I'll just do that quickly. We would have times the square root of 2 over the square root of 2. This would be 25 times the square root of 2 over 2. So that's your x value. That is your height and base. The base could be this part, the height would be that part. Or if you said the base was this part, the height would be this part instead. So you've got 1/2 of 25 times the square root of 2 over 2 times itself. 25 times the square root of 2 over 2. Another way to tackle that one here would be to use a Pythagorean theorem. I'll do that off to the side here. I could have said x squared plus x squared equals 25 squared. Leg squared plus leg squared equals hypotenuse squared. You'd have 2x squared equals 625. You divide both sides by 2 and you'd get 625 over 2. And then you would take the square root of both sides. You'd have x is the square root of 625 over 2. The square root of 625 though is just 25. So you'd have 25 over the square root of 2, and then you could do to get the same thing that you had here. So either way you do it, you get the same thing. So with this, what I have left, I've got all this on the bottom. I've got 2 times 2 times 2, that's 8. And I've got 1 times 25 square root of 2 times 25 square root of 2. So outside the square root, I would have 625. Inside the square root, I'd have the square root of 2 times square root of 2. That'd be the square root of 4, which would just be 2. So this is all going to equal so that would be 1250 divided by 8. And I'll bring up a calculator here. So 1250 divided by 8. That would be 156.25 rounded to the nearest tenth. We could do that. I feel like we could just leave it like that though too on this one, since that is an exact value. It doesn't have to be rounded. So I would take this on this one if you were one of my students. Or you could say that's approximately 156.3. And because of the directions written the way they are, I would accept either one of those. Number 9. So an equilateral triangle has a perimeter of 48 yards. Find the area of that triangle. So I'll draw the best quick equilateral triangle I can. That looks pretty good there. Equilateral means these are all the same. And the perimeter is 48 yards. So 48 yards here. That means the side length would be 48 divided by how many sides there are? 3. So you're going to have 16 yards for the side length here. So you'd have 16 here, 16 here, 16 here. We're trying to find the area of that triangle. So really we need to know what the base and the height are. We've got the base. We've got a base of 16, but then the height would be this perpendicular part here. So I don't know what that is yet. I could call it h. A few ways you could tackle this one, or at least a couple that I'm thinking of. We know that this is equilateral, so that means that all the angles would have to be 60 in the corners. So 60 degrees here. So you could use, at that point, you could use some trig to figure this out. You could say the sine of 60 equals h over 16 and solve for h from there. We're trying to get the area of the triangle. That's going to be 1/2 base. So the 16 would be the base, and then the h would be derived from the sine of 60 equals h over 16. One way to do it. Another way to think of it is, since this is 16 and this is an equilateral triangle, it's going to split, the height will split these two sides into 2 equal parts. So you could say that's 8 and 8, and you could use the Pythagorean theorem from there and say 8 squared plus h squared equals 16 squared. So that's a second way you could approach this problem. you could solve for h from there. So this was the first way. You could say the sine of 60 equals h over 16. Solve for h. You could use this, or you could use the 1 to rad 3 ratio, since this is going to be a 30, 60, 90 triangle right there. So if I use the ratios, this would be the third way I could tackle this one. This would be 2x, this would be the x, and this would be x times the square root of 3. So we would find, so we might as well just take that, multiply by the square root of 3, and we would get h is going to equal 8 times the square root of 3. So if you use this or you use this, you would get the same thing as this. If you're using this, you might get a decimal approximation, but that decimal equals 8 times the square root of 3. So from there, I can take that and plug it in. I have 1/2, the base would be 16, the height perpendicular with respect to that base would be this 8 times the square root of 3. So this is 1/2 of 16, that's 8, and then times another 8 would be 64. So I have 64 times the square root of 3, or approximately would be 110.9 yards squared. Number 10, this looks like a trapezoid to me, so we're going to assume that we can trust the looks here on this worksheet. I'm saying that this side's parallel to that one. And the area of a trapezoid is the average of the bases times the height. So average of the bases here, you're going to say 10 plus 15 divided by 2. That's the average of the bases. That's the median of this trapezoid. And that times 7. This would be 25 over 2 times 7. That would be 175 over 2. And that is going to equal 87.5 yards squared. Number 11. The trapezoid is isosceles. So we can assume that these two are congruent to each other. AD, it says, is 9 centimeters. D is 15. And the measure of A is 60 degrees. So that's 60 degrees right there. Find the area of the trapezoid. So if we're going to find the area of the trapezoid, we need the two bases and we need the height on this one. So here I'm missing a couple things. I don't know the height, but I could figure that out. This one isn't quite drawn to scale. That 60, that's a little bigger than 60 in the picture drawn to scale wise, but assume that's a 30, 60, 90 triangle then. So assume that's 30, that's 60, and then this angle is 90 right next to that. So you have an isosceles trapezoid. That means it's going to be the same over here. So we've got another right triangle that's just like that over here. And if this is 9 and we want to figure out the h, we can definitely do that if we know that that is 60. So I've got 15 here. I'm not sure what that is from here to here. I know it would be from here to here, another 15. But again, I don't know what that part is. I don't know what that part is. So let's figure that out. Let's call this x right here. So to figure out x and to figure out h, you could use your ratios. You could use the 1, 2, rad 3 ratio. You could use trig as well, but I'm going to stick to the ratios since we should get practice with those, I feel like. So if you're going to use the sine, cosine, tangent, you could say, I'll just write this off to the side. If you're going to use that, you should say for h, you would have to say that we have opposite and hypotenuse. So you'd have to say sine of 60 would equal h over 9. And for the x value, you'd have to say the cosine. This is adjacent. The x is adjacent. So cosine of 60 would equal x over 9. So if you're going to use trig to solve for x and h, use those two things. You're going to use the ratios to solve for x and h. This is your 2x part. This is your x times the square root of 3 part. And then this is your just 1x part. So we're going from the 2x to the 1x. You're going to divide by 2. 2 to 1, divide by 2. So that means x would be 4.5. And then if you know 4.5 and you're going to go from the 1 to the rad 3 ratio, you're going to multiply by radical 3. So that means h, that would equal 4.5 times the square root of 3. So we're going to use that for your height, and we're going to use x is 4.5. So this is 4.5 from here to here. That's got to be the same then over here. This is another 4.5. So your second base, let's call this B1. Your B2 is going to equal 4.5 plus the 15 here to here, plus another 4.5 from there to there. So 15 and two 4.5s added together. Your base 2, your second base, that would be 9 for these two together, plus 15 would be 24. So there's your B2. Your B1's right here. Your H is right there. We've got everything then we need to solve for the area. So the area is going to be the average of the bases times the height. We know B1, one of the bases is 15, the other one is 24. We're dividing that by 2 and multiplying that by the height. So times 4.5 times the square root of 3. So if we calculate this, this is 39 over 2 times 4.5 times the square root of 3. And it looks like that's going to be 19.5 times 5 times the square root of 3, which in the end we would get approximately 152.0 if we round that correctly to the nearest tenth. So that's centimeters squared there for the area. Number 12, trapezoid Abcd has a perimeter of 45 inches. One leg is 6 inches and the second leg is 9 inches. If the height is 3, find the area. So let's draw a picture once again. So trapezoid, perimeter, and leg. So it's not an isosceles trapezoid because these legs are different sizes. And let me try to draw this to scale as best I can. So it says one is 6, so I could have something like that perhaps. The perimeter, this won't be drawn to scale exactly, but one of the other legs is a little bit longer. I'm going to say that one's 9, and then the height is going to be 3. So I think this is going to give a pretty decent picture of what I'm looking for here. So I'm saying this is 6, this one's 9. These are the two legs of the trapezoid. The legs are the non-parallel parts of a trapezoid. So those are the parallel parts. The height we're saying is 3. So from here perpendicular to there is 3. And the perimeter is 45. So if the perimeter is 45 and this one's 6 and this one's 9, I could set up this equation. I could say this is B1, I could say this is B2, and from there I can say 45 would equal, the perimeter would equal B1 plus B2 plus 6 plus 9. So 45 plus, or equals, B1 plus B2 plus 15. If you subtract 15 from both sides, you're left with 30 equals the two bases added together. So I can just use that. My formula that I'm using looks like the average of the bases times the height. So I don't need to know each one individually. I can just take that and plug that in right there for the whole thing, for B1 plus B2. So I'm going to have 30 over 2 times the height. I know the height from the information was 3. This would be 15 times 3. That is going to be 45, and that would be inches squared on this one. Number 13, find the area of the figure. This looks like a, well, what does that look like to you? This looks like we have a diagonal here and a diagonal there. Looks like we have a, I guess they changed the wording of this around. I have a different copy that I'm looking at as I'm going through this with you. So this, we're going to find the area of this figure. And we're going to assume that this is a rhombus, actually. So I feel like that should have stayed the way it was on the old copy I have. I'm not sure why that got switched around. So we're going to assume that this is a rhombus, that this is all perpendicular. I guess, yeah, you could actually, this makes sense now, because each one of these triangles is a 10 by 15 right triangle. That would mean that all these hypotenuses, hypoteni, I'm not sure on that one, but each hypotenuse would be distance from there. So we can assume this is a rhombus. We can assume all the sides are equal. So you have d1 times d2 divided by 2, or you can think of that as 1/2 of the diagonals multiplied together. So 1/2 of d1 times d2. So that would be 1/2, and d1 would be 15 plus 15. That would be 30. So I'm going to write that in though. And then d2 would be 10 plus 10. So that's 1/2 of 30 times 20. And then 30 times 20, that's 600. Half of the 600 would be 300. So this one would be 300 meters squared. And so I didn't really need to cross that out on this one. I could say just a figure, and we can assume based on the information in the picture that since all these right triangles have the same measurements, the hypotenuse is going to be the same on each, making it a rhombus. Number 14. Find the area of a circle whose radius is 13 feet. So here's a circle for you, and the radius is 13. So we're just saying from here to here, 13 feet. The area of any circle is pi r squared. So this would be pi times 13 squared. An exact answer would be 169 pi. An approximate answer to the nearest tenth is going to be 530.9 feet squared. So 530.9 feet squared. Then find the area of a circle having a circumference of 36 pi. So let's see how that one is different. I'll draw a little bigger circle on this one. And so I don't know the radius on this one, but I know that the circumference is 36 pi. And then a formula you need to know is that circumference is the same thing as 2 times pi times the radius. So if that's true, and the circumference also equals 36 pi, I can solve for r from there. I can divide both sides here by 2 pi. Pi's cancel, the 2's cancel here. This would reduce down to 18. So I would have r equals 18. I can use that and plug it into the area formula. So pi r squared becomes pi times 18 squared. And 18 squared is 324. So 324 pi, that would be approximately 1017.9 units. So 1017.9. There's no units given on this one, so I'm just going to say units squared. Number 16. Find the area of a regular octagon with a perimeter of 96 yards. I think I actually have an octagon shape here. Is that the octagon? Yes. So let's see if I can get a regular octagon here. That looks pretty close to a regular octagon, and I'll just rotate it to make it a little, I think, a little easier to show you what's going on here. So this could be your center point. I'm looking to make a little triangle here to help me figure this out. And I think I actually want to make this bigger though, just to make it easier to see what's going on. So I'll expand this out a bit. And then drawing the center point of that octagon would be approximately right there. And then a triangle is something that I'll need to draw in here to think through this one. So the area of a regular octagon, we know an octagon has 8 sides. Perimeter is 96. That's going to be important here. That will allow me to get this side length. My S value is going to be just 96 divided by how many sides there are. 96 divided by 8 is going to go right there. So 96 divided by 8, that's going to be 12. So from here to here is 12. And then from here to here would have to be 6 then, and this would also have to be 6. This is going to split that in half. It's regular, so we know that all these triangles are going to be the same. If I made another triangle here and another triangle here, and I made 8 of those triangles, they would all have the same area. So that's the approach here. We're going to try to find the area of one triangle and multiply it by the number of sides there are by 8 sides, by 8 triangles that we could make. So here we're going to call this, instead of the height, we're going to call this the apothem in these problems. So it's the height of the triangle that can be made. We call that the apothem. This angle right here, from here to that spot right there, would be 360 divided by 8, because you can make 8 of these triangles, but then that divided by 2. So 360 divided by 8, then divided by 2, that would be 45, and 45 divided by 2, that angle right there is going to be 22.5 degrees. So if this is 22.5, you have this side, you want to know that side. We're thinking trig here. This is the hypotenuse, this is the adjacent to that angle, and this is opposite 6 of that angle. So which one uses opposite and adjacent? That's going to be tangent. So tangent is going to allow me to solve for A. The tangent of 22.5 degrees, so this right here, hypotenuse is across from the right angle, opposite of that angle that I'm looking at is 6. So this would be TOA. SOHCAHTOA, so opposite over adjacent is A. You can solve from there. You could cross multiply and get A times tangent of 22.5 equals 6. You can divide by a tangent of 22.5 from there. And we're going to get A equals 6 divided by tangent of 22.5. I'm going to leave it like that for now. If you wanted to approximate it to get a good estimate, that would be fine from there. So if you did approximate it, you would get about this, 14.48528, to 5 decimal places at least. So we know the area is going to be 1/2 of the perimeter times the apothem. You can think of it that way, or you can think of the perimeter as being the number of sides times the side length times the apothem. So either one of these formulas gives you the same thing in the end, whatever you feel better using. You can use that. Since I already know the perimeter is 96, I'm just going to use 96 instead of 8 times 16, or 8 times 12 I mean. So 8 times 12 is the same thing there as 96. The apothem is 6 divided by the tangent of 22.5. So I'm just taking that value, that's getting plugged in right here. And that is approximately, if you type all that in a calculator, you're going to get about 695.3, and this is in yards, so yards squared right there. Number 17, find the area of a regular nonagon. So a nonagon, you've already got the height given to you here. That's going to be helpful. And we're just going to have to figure out the length of that base. If it's a nonagon, the little angle inside here, we could make 9 of these triangles. So this angle right here would have to be 360 divided by 9 split in half. So that's going to be 40 divided by 2, which is 20. So again, that was 360 divided by 9. That gets you the area of the whole thing from here to here. And then that divided by 2 would be 20 from there. So you have a 20-degree angle there. You've got a right angle here. We're going to try to figure out what is this value right there. What is your x? So to find that, you could use, it looks like we have opposite and adjacent. We don't need the hypotenuse to figure this out. So we could say tangent of 20 equals opposite is x over 19. Cross multiply and you get 19 times the tangent of 20. You could write that over 1 if that helps, and cross multiply like that. So 19 times the tangent of 20 would equal x. So if this is x and this is x, the whole side length is really what we want for the base of this triangle. We have the height is 19, the base would be 2 times bigger than that. So we have that times 2 is going to give me my S value. So S would be 38 times the tangent of 20. The side length is that. So here, I think it makes more sense to use this idea, this thought instead. So we have area is 1/2 times the number of sides times the side length times the apothem. So we have 1/2. The number of sides is 9 in the nonagon. The side length was 38 times the tangent of 20. And the height, the apothem of the triangle was 19. So that times 19. If you put all this into a calculator, you are going to get your answer. And it looks like that answer would be approximately 1,124 points. Oh, I'm sorry, not that. 1,182.5. And no units given on this one, it looks like, so we could just say units squared. Number 18, we're trying to find the area of the region and assume that the inscribed polygon is regular. So we're going to assume this is a regular hexagon and that this is a circle. It looks like the diameter of that is 50. That would mean that we have, let's see here, I'm going to draw, let me use blue for that. So this triangle, I'm going to want to find what that is, and then I'm going to want to find this green part would be the apothem. We know that's a right angle down there. So let's fill in some stuff. We know all the way across here is 50. So that means each one of these parts, the radius here would be 25. The radius over here would be 25. If this is a hexagon, we know that all these angles have to be, it has to be 120. If you do the work to get those angles that you want, we're going to have n minus 2 times 180, 6 minus 2 times 180, divided by 6, the number of sides. You'd have 120. So that's one way to think of it. Another way to consider this would be this angle is going to be 30 degrees right there, because you have 360 over 6, that split in half, divided by 2. So that's a 30-degree angle. If this is 90 right there, that means this would have to be 60 right here. So there's different ways you can think about this one that didn't work before, because now you have a special right triangle that we know about, the ratios, 30, 60, 90. We know that this would have to be an equilateral triangle. So if this is 25, 25 here and here, we know that this one would also have to be 25. These are all going to be equilateral triangles here, here. If we made more here, we'd have equilateral triangles up. So that means all the way across down here would be the same thing, 25. The base is going to be 25, or the side length, 25. And then from here to here would have to be half of that, 12.5 here, and another 12.5 from there to there. So if we're going to try to find the height, we could use trig at this point, or you could use special right triangle stuff. So I'm going to use special right triangles because it goes a little faster here, but you could use trig as well. You could say, you could use 30. You could say the sine of 30 would be 12.5, or I should say the tangent of 30 would be 12.5 over the apothem. So I'm going to call this A. So I could use that, or I could use the 30, 60, 90 stuff. So if I use that, I know that this part is the part. Oh, come on. This part is the 2 part. Sometimes it keeps skipping here. This is the 2 part. This would be the 1 part, the 12.5, and this would be the radical 3 part, the A. So if we're going to go from 12.5 to the radical 3 part, or the 1 to the radical 3 part, I multiply by the square root of 3. So that means the apothem A is going to equal 12.5 times the square root of 3. So I can use that. I can use all the information I have in my picture to now calculate the area of the hexagon. So the area of the polygon, the hexagon, is going to be 1/2 times the number of sides times the side length times the apothem. So we have 1/2 times the number of sides would be 6. The side would be 25 right here, and the apothem was this. So times 12.5 times the square root of 3. And then all that multiplied together ends up giving you, and I'm just verifying my answer here. Yeah, it should be approximately 1,623, and it'll be about 0.8 there. So I'll use that. Why don't I give you this with more decimal places initially? So 7976, and that's going to be rounded to the nearest tenth, 0.8. So that it would be in feet squared, since we have feet here. So I'll put that down here, 1,623.8 feet squared. The circle, this should be a lot easier to figure that out. I'll do this in purple. So the circle, area of the circle is the, come on, don't skip around on me, pen. Come on, man. Pi r squared. And r is 25. So 25 squared, that's 625. 625 times pi is approximately excuse me, I'm looking for that. What was 625 times pi? There it is, approximately 1,963.495. So rounding that to the nearest tenth, 1,963.5 approximately. So I'll put that in here, 1,963.5. It should make sense that that circle has a little more area than the hexagon because it's bigger. It's around the outside. So the shaded area, I'll finish this in black. The area of the shaded part is going to equal the area of the circle minus the area of the polygon, the hexagon in this case. So we know those values are approximately 1963.5 minus 1623.8, so that is going to be 339. It's a huge squiggly equal sign there, approximately equal to that many feet squared. So I'll put that down here. So that would be my final answer, shaded region, but we're looking for all three parts written in here. Number 19, find the area of the figure. I'm going to color code things like you see here. So the area of the whole thing is going to equal the area of the rectangle that you see here plus the area of two half circles. You put them together, you get a whole circle. So the area of the circle. So this is going to equal base times height for the rectangle, and the circle is going to be pi r squared. So it looks like it's 30 all the way across here. It's 15 going this way. So that means the radius from here to here would be half of that, would be 7.5 feet. So for your rectangle, you got a 30 by 15 rectangle, so 30 times 15. And for the circle, you've got pi times 7.5 squared. And if you were to calculate all of that all together, you're going to have, this would be, looks like 450, and then you'd have 7.5 squared times pi. Subtract all that and put it all together, you get approximately 626.7, that many feet squared. Number 20, we can assume on this one that this right here is a semicircle or a half circle. So we're going to try to figure out what is this radius based on the information in this picture. So it looks like if this is 50 and this is 30, you can assume that the way things look are the way things are. So right here, I say this looks like a square to me, so we're going to say that this is 30 from here to here, leaving 20 from here to here. Actually, no, I'm misthinking of that. I just realized, what am I doing? Hold the phone there, Mr. Wagner. You don't have to think of it like it's not a square, actually. So we can't trust that part. But we can trust 30 is all the way across. Not thinking about that. 30 is all the way across. So the radius of this would be half of that, 15. All right, my apologies there. We have, for this rectangular portion, we're going to have a 30 by 50 rectangle. For the half circle, we're going to have 1/2 of pi times 15 squared. So the area of the figure is going to equal the area of the rectangle on this one minus the area of the half circle, or the area of the semicircle, you could say. So that would equal base times height minus 1/2 pi r squared. So that's going to be 30 times 50 or 50 times 30. It doesn't really matter what order you would write those in. Minus 1/2 times pi times 15 squared. That would be 1500 minus, and this would be 225 divided by 2, so that'd be 112.5 times pi. If we approximate that, we get our final answer. That would be 353.4, that part. We subtract that from there, we get about 1,146.6. If we round that to the nearest tenth. So about that many feet. 21. Find the area of the figure that you see here. So I see a triangle, the black part, and I see a rectangle, the blue part. So the area of the figure in this one, I'll say the whole thing will be in green, will be the blue part, the area of the rectangle, plus the black part, the area of the triangle. So we have here 12 times 5 for the area of the rectangle, base times height. And the area of the triangle would be 1/2 base times height. So you have 1/2. The base, we're going to assume this is perpendicular. The base is 12 all the way from there to there. And the height connecting that to the base in a perpendicular way is 15. This would be 60. And half of 12 is 6. 6 times 15 is 90. So we have 60 plus 90. The area of the whole figure then would be 150. No units given, so you can just write the word units, and that is units squared. And then finally, the last one here is going to be 22. So if you look at this one, it's not a real nice shape there, but you could say that this is one triangle, this is a second triangle, a third triangle, and a fourth triangle. So if I put all those things together, the area of the first triangle would be, it looks like 1/2, this would be 4 times 3. So 1/2 base times height becomes 1/2 4 times 3, which would be 6 right there. I'll do these other ones in different colors just to make it that more clear as to what's going on. So let's call this one 2. The area of the second one, the second triangle, you have a base of 5 and a height of 3. So you have 1/2 base times height is 1/2 of 5 times 3, which would be 7.5. The third triangle, I'll do that in red here, would have a base of 4 and a height of 4. So the area of the third one is 1/2 base times height. That's 1/2 4 times 4, which would be half of 16. That's 8 right there. And then the last one I'll do in purple. So the area of the fourth one, another 1/2 base times height, still a triangle. You have 5 for the base, 4 for the height. 1/2, 5 times 4. Half of 5 times 4 would be half of 20, which is 10. So if we add all these together, the area of the figure is all of those added together. 6 plus 7.5 plus 8, 10. And that would be, it looks like I'd have 14, 24 there, 31.5 if I add all that together there. So 31.5 units squared. Another way you could have approached this problem was just to use two triangles. So I could have said 1 and 2 make this bigger triangle together. The base would be 9 and the height would be 3. And then 3 and 4 make another triangle together. The base would be 9, the height would be 4. You could also do that with 1 and 3 and 2 and 4 instead, but somehow putting triangles together in the end to get the area of the figure. Go back and review, pause, rewind as many times as you need to help you with that. That finishes the excuse me, the video here though. Hope you found it helpful. Feel free to comment, like, share the video. If you have any questions or concerns, let me know if you're one of my students in class, or you can just comment on there. If you see a mistake, I appreciate you telling me exactly the time that happened in the comments, and then I can refer to that or make a comment on that. So I hope you found that helpful. Have a great night. Well, if it's night for you, it's night for me right now. So I'm going to hopefully have a great night. I hope you have a great day, great night, whatever you got. I will catch you guys later.